So in solving this graphically, you must be able to choose your first point to draw. I'm referring to the point. A point is where all the forces intersect. So here we have this and this and this and that, which they intersect here. So this one becomes a point. So this one, we have this member, that member intersecting there. That is also a point. So all in all, how many points do we have there? Sorry? All in all, how many points do we have here? All in all, we have 5 points. Point number 1, point number 2, point number 3, point number 4. There are 4. So, point number 1, I can extract it as like, I draw it the way it is. This would be point number 1, meaning I come and cut here. I only focus on this point number 1. Then from there we go to the second point, third point, just like that. So now, before you draw, you must choose the point to start with. You must choose the point which you must start with. So, the forces, for instance, if we're having this one, which is 50 kilonewton, and this one, and this one going up, how many members there? How many members does they have known value? It's only one, eh? Yes. Yes. This one, this is a member, right? Yes. We only have this one as known. So you need to choose your starting point. So your starting point, we must at least have one known. You must at least have one known. Meaning you must check all these points before you can choose which one to start with. You must check which one it has at least one known. And the point which you choose, it must have 1 or 2 unknown. It's either there is 1 unknown or 2 unknown. Once there's 3 unknown, you cannot start with that point. You get that part, ne? Do you understand? Yes. Okay. So on the board, when you check there, which point can we start with? Is there any point with at least 1 known and not more than 2 unknown? Which point is that one? Point 1. Sorry? This one. This one we have, this is going down, going to this direction, and this one is 60 and 50 there. Do you know the magnitude of this one? And this one? And this one? This one we cannot start with this one because we already have 3 unknowns. Ne? So the unknowns, they must be 2 or 1. So in this case, if you check all, there's no point with 2 or less unknown. Eh? So in the situation like this one, we will be forced to calculate what? The reaction first. We'll be forced to calculate the reactions. So, but we are not going to calculate the reaction today. I will just write the magnitude of those reactions, which is, for this one is 51.65 kilonewton, and this one is 23.39 kilonewton. But I'm still going to show you how to calculate it, but not today. So now, which point it qualifies for us to start with? Sorry? 0.1, eh? It's only 0.1. Endpoint? And 0.4. Yes. If you come here at 0.4, we have this one going up as 23,39. We have this one and this one. So on this one, we at least have one known, and we have two unknowns. So this one, it qualifies. Also, this one, it also qualifies for us to start with. You get that part, ne? Yes. So, but before you extract a point, you need to name your members. Before you extract, you need to name. Between each and every member, you must have an alphabet. We have this member, we have alphabet, two of them. We have this one, we have this and this. This one, that and that. This one, this and this. This one. This one is between which one and which one? Sorry?
F and I.
F and I. This one is between, if you check, there's no any other alphabet. Doesn't matter where it's written. But this one is between E and F. So the I is this one, which is between I and what?
E.
And E. So this one is between which one?
H and I.
H and I. And this one? F and G. This one? A and F. Just like that. So, if you found it numbered, you do not have to change their number or the way they name their members. You're supposed to solve the way it is. But if they are not, you can do it by yourself. And make sure that you do not put more of alphabet. Just for instance, you come here, you said here is E for this one, and here you said this one is maybe K. You said this K is for this one and this one. Already on one space you have placed two alphabet, which is wrong. You only need one alphabet. So, this one is between A and B. Ne? This member is between A and B. Meaning, we are going to name this according to these two alphabet. Meaning, this is AB. So, let us extract that point. Let me draw it down here. We have 50. This one is 51,65 kilonewton. Then here we have A. This one we have B, 50 kilonewton. And this one we have G. Now I have extracted the point there. So after extracting this point, I need to know the name of this member. What is the name of this member? Sorry? AB. This one? BG. This one? Sorry? FG. Okay. When we name them, when you name them, you should go clockwise at the point. When you name them, you should go clockwise. So we start. The name of this one? This one? This one? GF. And this one? FA. When you name them, you go what? Clockwise. So, So now we are going to start with our drawing. We are going to draw a vector diagram. So the given one, that one on top, that is a space diagram. So with a vector diagram, when you draw, you start with the member which you know after unknown. The member which you know after unknown when you draw. A, you start with a known after unknown. So in this case, which one is a known in this one? 15, eh? And it's the only 15, eh? So on this one, on this point, if we're to draw, remember I said, let's say we have already extracted this one. We have already chose this one according to the criteria. Then which one were we going to start with between 60 and 50? Remember, you start with known after unknown. Which one are you going to start? Are you going to start with 50 or are you going to start with 60? 60. Why? It's a known after unknown. Eh? Remember, we go clockwise, right?
Yes.
As we go clockwise, between the two, as we go clockwise, which one is a known after unknown?
6.
The 6. I think this one is unknown. 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 This is a known. Meaning, when you draw, you should start with this one. You get that part, ne? Yes. So in this case, no problem because we only have one known. So in this case, you must choose which force to start with. You understand that part, ne? You don't understand? Okay, let me draw another point randomly from nowhere. Here is 20 kilonewton. There you have 30. Here is 60. Then you need to choose a member to start with. We have A, B, okay. We have A, B, C, D, E. So we said when we name them, we go clockwise, right? Yes. So meaning this is AB. This one is EA, right? So now I'm saying, for us to draw a vector diagram, first you need to choose a point. We did choose a point. Now we want to start drawing a vector diagram. Before you start, you must choose which member to start with. In this case, are you going to start with CD or with DE? You need to start with the one which you know the magnitude. You know the value. So in these two, we know CD and we also know DE. It's obvious that we won't start with this one because this one is unknown, and we won't start with this because as well as that one. Because these three are unknown. Yes. Oh, yeah, thanks. Thank you. We won't start with these two, ne? But we need to start with one between the three. We need to start with one between these three. You don't just choose any and start. You must start with the known after unknown. So which one here is a known after unknown when you go clockwise? Do you get it? CD, as you go clockwise. Even if I can start here, is this a known after unknown?
No.
But after this one is a known. Also, this is a known, meaning this is a known after known. We cannot start with this. This is a known after known. When we go clockwise, we cannot start with this. So this is a known after unknown. So therefore, you need to start there. You get that part, ne? Yes. So, okay. Now we did choose our point. Anyway, how did we choose this point? How did you choose to start with this one? It had what? It has less than 2 unknown, eh? And there's another thing? And at least 1 known, eh? Yes. You must have these 2 criteria before you start drawing. The criteria must be both of them qualifies. Okay. Now then that, in this case, which one are we going to start with? AF, ne? Yes. Yo, FA, ne? FA is the first known after unknown. Yes. And in which direction? Vertical upwards. I'm talking about FA. FA. Now we're talking only FA. In which direction does FA goes? Upwards. And now we need to draw. So going clockwise is the sequence of taking all those members. But for only this member is going upwards. So this member is FA. FA. So we know that somewhere here or somewhere there is a start and there is where it ends, as we are going to draw. We know the magnitude of it, and again. So as we draw, it goes up, upward direction. So I want to know between the top part and the bottom part, which one is F? The what? The bottom part is F. Why this one will say is F? Okay. This alphabet, the other one it must be there, the other one must be there. So for now we know that this is FA. So for you to know where to put which one, you need to follow a tail to head method. Tail to head method. Tail to head method, right? So as it goes like this one. This one is what? FA, right? FA. Tail to head. FA. So with the help of the arrow, where should I place F? At the bottom, right? And on top? A. If this one, I had it like this one, then it say FA. What is F? A is what? This is A. F A. Is this one what? F. This is F, ne? And this one is A. So if ever we're having AF is same, but it's AF. What will be this one? A, and this one? F. Can you see? This thing, they connect from this here. Remember we said we number them clockwise. So we already know that when we go clockwise, this one is FA. So this FA, it will also assist you in there. So okay, now we are going to draw. How do we draw? In a ruler, we do not have kilonewton. Right? Yes, in a ruler, we do not have kilonewtons. So we are going to look on the scale, or we are going to select a scale. A scale, you will indicate that for every 10 kilonewton is the same as having what? 10 millimeters. This is an example. But your measurement, if you can say 10 kilonewton is equals to 50 millimeters. Can you see that? At the end, if you're having bigger values, it won't fit in the page. You should be able to select the scale by yourself. But sometimes they give you a scale. If you're not given, you're supposed to choose your own scale. If I check my drawing here, or my forces, this one is the largest. If I say 10 kilonewtons equals to 10 millimeters, just for example, do we have 50 millimeters in the roll? 60 millimeters in the roll? We don't have 60 millimeters in the roll. 60 millimeters. We don't have ruler. And how big it is? Let me see. Yeah, it's reasonable. Let us use that one. It is reasonable. So, okay, now we are going to start drawing. Now we are going to use the scale 10 is equals to that one, right? Yes. So, which one do we start with here? FA, ne? So, do you have protectors? Okay, today I will just talk. Tomorrow you need to bring them. Even the ruler, ne? Yes. So now, here is my, from there to here, it's going up. How long from there to there? 51,65 millimeters, right? And this force is going up, right? This, yes, is going up, is there. And then, what is this point? It's F, ne? And this one? Is A. After this FA, it was going vertical up. Yes. So now I'm done with drawing this one. I need to draw this one. And what member is this one? AB, right? So my AB, I need to attach it there. But before I attach it, you are saying it's AB, right? So, and it goes to this direction. What's A? On the left, ne? And what's B? On the right. So, I already have A. You see that one? So now I need to draw this member. It means I need to attach there. So do I draw it going to the left or do I draw it going to the right? I draw it going to the right. How long? 50 millimeters, because 10 is equals to 10, yes. So this goes to this direction, and which point is this one?
B.
That is point B. So okay, now I'm done with this two. I'm going to draw this one. And which one is this one? BG. So in which direction does BG goes? Does it go up or down? Sorry? Diagonal up or diagonal down? How do you know that is up? What if I come here and put the arrow there? Which direction? Down. What if I put the direction, this one? All I'm trying to say, guys, is we do not know the direction of BG, ne? Yes, we do not know the direction of BG. So, because we do not have drawing instruments with you, I'll refer a bit on my notes so that I can estimate in which, I'll make the measurements so that at the end we'll get the same thing. But tomorrow when you come here with drawing instruments, you'll get to see that I was correct. So, okay, BG. We already have B, ne? But we do not know where's what? G. So at B is then where we should draw BG. And BG is diagonal. You draw it the way it is. This one was vertical up, horizontal. This is also horizontal. What about B? G. If you come here, this is BG, right? If you check, BG is 60 degrees from the horizontal line. Meaning, at this point, you can just draw a small Cartesian plane invisible. Ne? Then you, from there to there, is 60. So actually, we are going to draw at B. So at B, you will also have that invisible small Cartesian plane. Then you measure 60. Actually here, when you are here, this is your point, right? You are measuring from here, going this direction. Same thing, say, applies here. You measure from there, going that direction, you measure 60. Because there is 60. Then you draw a line. It goes that direction, it also goes to this direction. Somewhere this side, you have G. and somewhere this side you have G. We do not know in which direction. If we say it's this side, it means we know that it is going up. And then we do not have an arrow to tell us that it's going up. If we say it's this side, we are saying it's going down. So, but because we do not know, it's better we draw a straight line which passes that point, as long as it's at the correct angle. Is there anyone who does not understand so far? You all understand? Okay. So now we will leave it like that. So we go for, sorry? GF, ne? GF as well is horizontal. GF is horizontal. GF is horizontal. But we do not know G if it's on the left or is on the right because there's no arrow, right? What we know that is on this diagram we have what? F. And we're going to draw what? GF. At least we know that this horizontal line, it must go through there. So when we are here, we draw a line going that side and we also draw a line going this side. Against GF, somewhere this side we have G and somewhere that side we have G. So when they intersect, actually here somewhere this side we have G and somewhere that side we have G. So they intersect here, it means this is your point G. So this one you can take it off. Because that one, it was just to help you find where's point G. So that one you can take it out. So now you do know your point G. So the question is point G going up or down? It's going down, eh? Yes. Why are we saying it's going down? It must follow this arrow. They must form a closed loop, right? So here it should go down, and here it will go to this direction. And after that, you are not done. You must come back to your spacer diagram. Close to the point. Again, for this one, you were not having an arrow for this one. Now on your spacer diagram, you need to have an arrow. GF, closer there. You see? For this one, where do I put it? Also closer to the point, eh? Is it up or down? Downwards. So from when I'm done transferring the arrows here, I take them off here. So the arrows are out. Yes. Should I? Oh, left. Actually, the first arrow it was going up. This one it was going this one. So this one it must form a closed loop. When it must form a closed loop, meaning the arrows must follow each other back to the start. If we take it up, it means this arrow they are going to opposite this one. Do you get my point? Yes. So they must form a closed loop from a vector diagram before you transfer them this side. So if you fail to transfer them here from point number 1, you're gonna have a problem to give the nature of your member, which we have struck and the tie. But I will explain that one once we are close to finish. So this one is out. Okay. Now, are we not done with point number 1? We're done with point 1, eh? Yes. So now we need to draw the next point. You need to draw the next point. We need to draw all the points. We cannot say we are done only one point. So it means this one we can take it out because we're done with it. We go to the next point. The next point, you are no longer going to choose the next point because it has blah, blah, and blah, blah. You choose the next point because it's closer to this. Meaning you cannot choose this one. You cannot choose this because both of them, they are not close to this. It's either you choose this one or you choose this one. It does not matter you go out. as long as the next point is closer to this one. You get that part, ne? So in this case, I'm going to choose this one instead of this one. My reason is this one will at least have a force. Not that this we cannot draw. We can, but for the fact that they're all unknown, it's a little bit difficult compared to when we have one known. And here we do not check how many unknowns. It's no longer applicable. It was only applicable on your first point. So the second point you choose because it's closer to this one. You get that part, ne? So now I choose point number 2. So when I extract point number 2, we have 20 horizontal at angle 60 at unknown angle. Here is G, B, C, H. So in this case, now we're at point number 2. We're going to connect point 2 and point number 1. So which member are we going to start with there? Sorry? BC, ne? We're going to start with BC. Can you see? B is already there. If you choose this one, all the alphabet, you wouldn't find them on this point. But now we do have B. It's easy for us to connect. In which direction does B goes? Okay, I want to know where's C. Is C somewhere on top or C somewhere down there? Somewhere down, eh? Yes. C is somewhere down. And the magnitude is 6, ne? And if we check, this one is AF, and AF is 51. This one is 60, meaning this one it will be a little bit more longer. Somewhere there, right? So here we have what? C is going down. Yes. It's 20. I mean, I'm looking on this one. I'm sorry, ne? Yes. So 20 is somewhere here, right? Yes. 20 will be somewhere there. This one is C. Down. So, okay, which one do we draw now? CH, ne? We at least know point C. Again, we have point C. There is point C. Yes. This point C. Now we need to draw CH, which is horizontal. So now we draw a horizontal line. Because we do not know the direction, we'll draw to all directions, as long as we know that is horizontal. So somewhere this side, we have point H, and somewhere this side, we have point what? H. So after that, which one do we draw? HG. Do you have at least one point? We don't have point H, we don't have point G. But we have point G there. Where point G is this one there? Sorry? So other here is HG, right? What is this angle here? 60, ne? This angle here is 60. So this is the point. At your point, you put your small Cartesian plane in visible one, right? When you measure from this one going down, you should measure 60. With a protractor. Obvious. So even here at G, I believe we need to connect with G. At point G, I will draw my smaller Cartesian plane invisible. So I will measure from here going down. I measure 60. So in that case, when I measure 60, I will draw that line. Somewhere this side, I have what? I have what? H. And somewhere this side, I have what? H. Where do they intersect? They intersect here, right? So, as they intersect there, it means this other portion here, these other lines, they are out. This point G, that is point H, CH, ne? So this one is out. H what? HG. That is the one that we just draw now. So now which one is left? GB is left. GB is left, right? Sorry? GB is already there. So there's no need of drawing, ne? So let us follow the arrow. Let us put the arrow for all of them so that we can transfer them there. Right? So okay, this one is going down, right? From here is what? CH, right? So CH, it means it will go to this direction. From CH, which member comes next? HG, it means it will go down. Then from there, GB, where, in which direction? Pezzo, right? So because we were drawing this point, next to this point, I will draw that one. BC is the arrow is already there, right? CH, here is the arrow to the left. And then this one, yeah, pants, ne? And this one goes up, right? Yes. If you check for BG, you already have the nature. Because can you see this arrow goes this direction, that arrow goes to that direction. So when the arrow oppose each other, the nature is extract. When the arrow fall like this what? It's a boy tie, ne? Boy tie. You know boy tie, ne? Yes. It's a tie. This one is a tie. This is a tie. So can you see if you do not transfer these arrows, if we do not transfer this one initially, we wouldn't know the nature. So it's very important that as you draw, you also transfer the arrow. But to tell the nature, we will tell the nature after we get the magnitude. So now let us, are we done with that this point, ne? Point 2 we are done. Let us go to point 3. Point 3, as long as it's closer to this one, I repeat, you take the one which is closer to the point which you just drawn. So now we just drawn this one, is either we take this or we take that one. So Mina, I opt to take this one because at least here we have knowns compared to this one. So okay, this one is out. That being out, I will have this point 3. This is C, D, E. So here we have H and I. 60 kilonewton, 50 kilonewton. So, which member do we start with? We start with CD, ne? Do we have at least one point? Is either C or D? Which one do we have? C. So at C, we are going to draw. Do we go up or down? We go down. Again, straight downwards for 60 millimeters. Because our initial scale, no, I wanted to do this one, you must check them out, this one. Once you're done with that point, you take them out. Meaning, even if you do not draw them, you can just draw the first one, then the rest you just follow and transfer there, so that your page does not get dirty. So this one here, it goes down, eh? Which point is this one? It's D, ne? Yes, it's D. We do know where's point D because we do have magnitude. And we do know that is down or is below C because we do have the direction. So what else are we supposed to draw? DE. So DE, it goes to This direction, right?
To the left.
To the left. For how many millimeters? 50, ne? It's horizontal. So, because I'm using a free hand, we are not drawing using ruler. We're not doing drawing according to scale. So, for my drawing to become more or less or equal, I just want to see if the point which I'm drawing now is greater than this one. If it's greater, so that I can pass here. If it's less, so that I don't reach there. So is this one greater than or less than this one?
Equal.
They're equal, ne? So it means I will stop at the same position. This one, which is what? Is what? Which point is this one?
E.
This point is point E to this direction. So from there, EI. EI, agree now we are drawing this point. From this point, I can draw my invisible Cartesian plane there. It's either I measure from here or I measure from there. So now I'll choose to measure from, okay, I have been measuring from here. Now I want to measure from this side, from there to there. How long from there to there? A stage, ne? Okay. Now I'm going to draw EI, meaning it's on my vector diagram. I should look for point E or point I. The one which is there, I should go and draw my EI there. So which point is there?
E.
Point E is there. So when I'm here, I will draw the very small Cartesian plane which is invisible. This is E. So I measure 30 from here. Even now I will measure 30 from there going that side, which it will go to this direction. Somewhere this side I have I, and somewhere this side I have I. So after that, which member comes next? IH, ne? Do you already have point H? Yes. So at H, the only thing now which I need to find is the angle. Same applies here. This is my H, small Cartesian plane on that point. Now I choose to measure from here, going this side. Which angle is this one? 60, ne? Yes. So meaning at H, I will have my invisible small Cartesian plane. I measure 60 from there. Then I draw. Is there any need to go that side? I already know that my eye is this side, ne? Yes, there is my eye. So I can take out the rest. Even this side, I can take it out. Is there any other point?
No.
HC is already there, ne? So okay, now we follow the arrow. Going down, CG is going down. It's already there, right? DF, DE, right? Is going to the right. It's already there. EI is going where? Up. And next to this point, I need to draw an upwards direction. I agree with this, the point which we're drawing. So IH also up, ne? Also up. Then HC to the right. Looking at this arrow and this arrow, what is the nature of CH? Struct, ne? Yes. The nature of CH is a struct. So okay. Now I'm done with point 3. Oh. Then to easy, ne? Echo is any question? No question? Okay, if no question, it means you understand. Okay, now let us go to the next point. Okay, let us draw point number 4. Point number 4, which one do we start with? Sorry? Which one do we start with? Agreed, yeah? This one is point number 4. So which one do we start with here? EF, ne? Is going up, right? Do we at least have one of the two? Which one do we have? Do we have E? And we also have F. And straight upwards, ne? According to what you have drawn, if I draw straight upwards to there, will it come out as a straight line? Like vertical up? Yes. Yes. So this one is going up. So now which one do we draw? FI, ne? FI is horizontal, ne? So now look where's my eye. It's because I'm not using a scale. I'm just drawing. I did not measure any angle. So it means this one maybe it was supposed to come somewhere there. If I was using a drawing instrument, it was gonna come somewhere there. So that it can come as a straight line. That is point I. So the last one on this point is IE. It's already there, ne? So it means what I need to do is just to put the arrows here. This arrow is already there. What about the arrow of this one? Up. This one's up. Sorry? Yes, to the left, ne? And this one? Down, ne? Again, we have this one. It's going up. This going to this. From this one is this one, right? From here, where do you go? Left. This air is supposed to go to this side, ne? And this one? Downwards. Yes. This one is supposed to go to this direction. So, okay. Now we're done with this point. We take out this arrow. After taking out that arrow, we draw the last point. On the last point, we have 60, F, H, I, and G. So this one, we have all of them, the unknown. Eh? So for you to know which one to start with, just check all the points there. If you have point I in our vector diagram, you can start is either HI or IGF. If you have F, it's either you start with this one or start with this one, depending on which one do we have. Again, here all of them they are unknown, and all of them they do not have direction. So which one do you choose? We can start with. Sorry? FG. Here we have FG, right? F. We have FG. Then after FG, which one comes? GH, right? After GH, HI. Can you see the arrows? As I'm talking with arrows. Then IF. Yes. Mm-hmm. Sorry? HI, yes. Already is corn. We do not air. Already is corn. You just check which point is there on the vector diagram. If those all points that are there, your thing is just to put the arrows. Pen. So if all points which are here, they are already here, yours to put arrows. It's either you come and follow the arrows or you come here. This arrow, as it goes that side, it's obvious this will go this side. Yes. There is no way the arrows, they will follow each other. Never. Arrows, they will never follow each other. Which way? Which one? This one. This is another member. Meaning this one here, they must go to this direction. We have this, can you see we have this member here? And we also have this member here. So these are the two different members. Yes, from point to point, you cannot pass to another point. This is a one member.
Okay.
Yes. So this one is obvious, this, it will go up and this is gonna go down. So now, being done drawing your spacer diagram, they will tell you which member they wanted you to calculate or to get the magnitude. If they wanted this bin, if they wanted BG, you come here, you look for BG. What's BG? Yes, BG. You take a measurement from there to there. If you get, let's take example, you get 63.5 millimeters. What will be the magnitude of BG? 63.5 kilonewton because of our initial scale, right? So what is the nature of BG? Sorry? Extract. BG extract. Meaning at in the brackets here, you will indicate S. Or you write in full extract. Then you are done. Is there any question? Because we are done. Sorry? Yeah, we are like with finding the magnitude, we are done. The only thing which is left is for us to be able to calculate the reactions if you have more, if you do not, you need to start here. So this one I will show you tomorrow. Yes?
Is it okay if I start with IF
At 0.5. To start with what? IF. It doesn't matter where you start with IF, as long as you can get 1 point there. Yes, as long as you can get that 1 point.